At the center of our galaxy, something massive waits in silence. It doesn't move. It doesn't glow. But everything around it orbits in fear. This is Sagittarius A star, a supermassive black hole over 4 million times the mass of our Sun. And it's not alone. There are millions of black holes scattered across the universe, each one stranger than the last. For decades, scientists thought they understood these cosmic beasts. But now, new discoveries are changing everything. Some black holes are growing faster than we thought possible. Others are making sounds we can't explain. And a few seem to break the very laws of physics. But what actually happens inside one? And why do some scientists believe they could lead to other worlds, or even other universes? To understand that, we have to start at the edge. It's called the event horizon, the boundary of no return. Once anything crosses it, light, matter, even time, it's gone. If you fell toward a black hole, you'd see the universe stretch and twist around you. Time would slow to a crawl. Your body would stretch like spaghetti. From the outside, you'd appear frozen at the edge forever. But to you, you'd fall fast. This isn't science fiction. It's the real effect of gravity taken to its extreme. And it gets even weirder. Because black holes don't just bend space. They bend time itself. Clocks tick slower near a black hole. Minutes stretch into hours, hours into days. In theory, if you orbited one closely enough, you could return to Earth and find that everyone you knew had aged, while you hadn't aged much at all. Black holes are time machines, but not the kind you can control. And what lies at their center remains one of the greatest mysteries in all of science. For years we believed black holes were simple. Matter goes in and it never comes out. But that idea hit a wall, thanks to Stephen Hawking. In the 1970s, he proposed something shocking. Black holes might not be completely black. They could emit something now known as Hawking radiation. If true, that means black holes can slowly evaporate over time, until they disappear. But that raises a disturbing question. What happens to the information inside? In physics, information isn't supposed to be destroyed. But if a black hole vanishes, where does it all go? Scientists call this the black hole information paradox, and so far, no one has solved it. Some believe the information is encoded in the radiation. Others say it's stored on the surface, like a cosmic hologram. Either way, the black hole isn't the silent vacuum we once imagined. It's active, it's complex, and it may even be connected to quantum mechanics in ways we don't yet understand. Recently, astronomers have found black holes that defy everything we thought we knew. In tiny galaxies, in the early universe, we're spotting black holes that are far too big to have formed so fast. They shouldn't exist, and yet they do. It's forcing us to rethink the rules, and some scientists now believe these anomalies might point to something even stranger. Black holes could be more than just dead ends. They could be gateways. Some physicists believe black holes could be more than cosmic traps. They might be bridges to somewhere else. According to general relativity, the intense warping of space and time could create shortcuts through the universe. These theoretical shortcuts are called wormholes. If they exist, a black hole could serve as the entrance, and on the other side, a white hole, an object that spits matter out instead of pulling it in. It's a fascinating idea. But there's one problem. We've never seen a white hole, not even once. Still, the math suggests it's possible, and some scientists think certain black holes could connect distant regions of space, or even parallel universes. It's pure theory, but not pure fantasy. The equations that describe black holes also describe wormholes. The only difference is what we choose to believe is real. As our technology improves, we're beginning to observe black holes more closely than ever before. But sometimes, what we find is even stranger than what we imagined. Not all black holes sit quietly in the centers of galaxies. Some are on the move. These are called rogue black holes, massive, invisible objects drifting alone through space, far from any star or system. They don't emit light. They don't give off a glow. They can only be detected by how they bend the light of stars behind them, or by what disappears when they pass through. Scientists estimate there could be hundreds of millions of them, silently roaming the galaxy. In 2022, astronomers captured the first possible image of a rogue black hole in motion, just 5,000 light-years from Earth. It's not heading our way. But the fact that it exists at all changes how we think about the cosmos. These wandering giants are relics of violent events, supernova explosions or gravitational slingshots that sent them hurtling through space. They don't follow rules. They don't follow patterns. And they could be anywhere. Hidden, silent, waiting. In 2022, NASA released something that sent chills through the internet. A sound, a deep distorted hum recorded from the Perseus galaxy cluster, where a black hole lies at the center. For years, scientists believed space was silent. After all, sound can't travel in a vacuum. But in this cluster, hot gas surrounds the black hole, dense enough to carry vibrations. NASA used special techniques to translate those vibrations into sound waves we could hear. The result? A low, ghostly moan, alien, haunting, like a warning from the depths of the universe. This isn't just noise. It's the sound of a black hole consuming matter, warping space, and shaking the very fabric of reality. We can't see it. We can't touch it. But now, we can hear it. It's a reminder that black holes aren't silent voids. They're active forces, shaping galaxies, bending time, and revealing just how little we understand. Black holes were once thought to be the end of everything. But the more we study them, the more they reveal. They bend time. They challenge physics. They produce sound, light, and maybe even answers to questions we haven't thought to ask. Some are ancient, some are new, and some shouldn't exist at all. They're not just the leftovers of dead stars. They're the engines of galaxies, and possibly the gateways to other realities. In the darkness, they pull us closer, not with gravity, but with mystery. And one thing is certain: the deeper we look into black holes, the more they show us about the universe and about ourselves. Because sometimes, to understand where we're going, we have to explore the places where nothing can escape, not even light.